Hey everyone, welcome back to AP Chemistry Rescue. I'm Mr. Hisham. Today we are moving on to skill number 2, Arrhenius Bases. Now in the last video we learned about Arrhenius Acids. Those are substances that produce H plus ions, hydrogen ions in water. Today we're looking at the opposite, bases. It's going to be really straightforward. If you understand the Arrhenius acids, the basis will make complete sense. We are just flipping the concept. So grab your notes and let's start. By the end of this video, you will practice 15 questions. All will help you to completely understand what makes something an Arrhenius base. Alright, let's start with the definition. What is an Arrhenius base? Arrhenius base, any substance that produces OH minus ions when you dissolve it in water. Let me say it again, slowly. Arrhenius base produces hydroxide ions in water. That's it. That's the whole definition. Notice I said in water, just like with Arrhenius acids. Arrhenius bases only work in aqueous solutions. That means water. If you dissolve something in alcohol, or if you have a gas form of the acid, like hydrogen chloride, without water, the Arrhenius theory will not apply here. Now let's look at the general equation. What do we write here? We write here that BOH in aqueous solution breaks apart into B plus and OH minus. BOH is just a placeholder, so the word B can mean any base. Can be sodium, potassium, calcium, whatever. The important part is that it has an OH group attached. And when it gets into water, that OH comes off as OH minus. Let me give you a real example. Sodium hydroxide. Sodium hydroxide, that's NaOH. When it dissolves in water, it splits into Na plus and OH minus. And what else? Potassium hydroxide will give you K plus and OH minus. So the metal becomes a positive ion and the hydroxide becomes a negative ion. They breaks. NaOH. All you have to do is write Na. This becomes plus because it loses an electron, and OH minus gains an electron, so it becomes OH minus. That's what makes it a base. That's the key player here. So remember, Arrhenius base equals produces OH minus in water. Write that down, repeat it to yourself. That's the foundation of everything we are going to do today. Let's actually see what's happening at the molecular level. Look at this diagram with me. Here we have a molecule of sodium hydroxide, NaOH. It's in water. Remember the definition, represented by these blue H2O molecules around it. Watch what happens when the sodium hydroxide dissolves. The bond between the sodium and hydroxide is going to break. The sodium atom becomes Na plus, and OH changes into hydroxide ion, OH minus. That's the red sphere with a minus sign inside it. They separate, they go on their own ways in the water. Sodium ion floats around as sodium plus, the hydroxide ion floats as OH minus. And it's that OH minus that makes the solution basic. That OH minus is the whole reason we call this an Arrhenius base. So every time you see a formula that has OH in it, like NaOH, KOH, calcium hydroxide, you should immediately think this is probably a base. It's going to release OH minus in water. Let's look at the equation underneath. The sodium hydroxide goes Na plus OH minus, simple, right? One molecule of sodium hydroxide, we cannot say molecule, let's say formula unit because this is ionic compound, produces one sodium ion and one hydroxide ion. Make sure you understand this visual. This is what's actually happening in the beaker when you add a base to water. The next slide, why is the charges form? Why it becomes plus and minus? Some of you might be wondering why the Na changed from Na into Na plus, why it became positive, and why hydroxide becomes negative. That's a great question. Let's break it down. Here is our NaOH molecule before it breaks. Sodium is bonded to the OH minus group. Sodium is a metal, it's in group 1 of the periodic table, which means it has one valence electron, one electron in its outer shell. This is the sodium. So 2 electrons in the inner shell, then 8, then 1 electron in the outer shell. Sodium really wants to get rid of that electron, right? Because if it loses that, it will change into 2,8. So the outer shell will be full. What does this mean? Stable, like the noble gas. Atoms love stability. So when NaOH dissolves in water, the sodium loses its one valence electron. Look at this diagram. The sodium loses that electron and becomes Na plus. The plus sign means it lost an electron. So now it has more protons than electrons. It has how many protons? 11. And how many electrons? 10 only. The plus sign means it lost an electron, so now it has more protons than electrons, making it a positively charged. Now what about the OH? Where did that electron go? The OH group has electrons already, and when sodium leaves one electron, the OH keeps the bonding electron. So OH ends up with an extra electron. Extra electron means negative charge. So instead of OH, you will become OH minus. That's why it becomes OH minus and it's called the hydroxide. Let me say that again in simpler terms. Sodium loses electron, becomes Na plus, positive charge. OH keeps an electron, becomes OH minus, negative charge. This is basic chemistry. Atoms move electrons around to become more stable. Sodium is happier as Na plus, OH is happier as OH minus. Water helps them separate. And that OH minus floating around is the water. That's what makes the solution basic. That's your Arrhenius base in action. Now, let's see. Time to test your understanding. I've got 5 recognition questions here. These are straightforward, just checking if you got the basics. I'm going to read each question, pause the video, try to answer it yourself, then unpause to check. Ready? Question 1. What does an Arrhenius base produce in water? Pause now and answer. The answer is OH minus ions. That's the definition. Arrhenius base produces OH minus ions in water. If you got that right, if not, go back to slide 2 and review the definition. Question number 2. Is sodium hydroxide an Arrhenius base? Pause. Yes, sodium hydroxide is Arrhenius base. It has OH in its formula. When it dissolves in water, it produces OH minus. That's textbook Arrhenius base definition. Is HCl an Arrhenius base? Is this tricky? No, it's not. It produces H plus ions in water, not OH minus. So acids produce H plus, bases produce OH minus. Don't mix them up. True or false? Arrhenius base works in any solvent. Pause now. False. Arrhenius bases only work in water. The definition specifically requires aqueous solutions. If you dissolve a base in alcohol or benzene or anything else, Arrhenius theory does not apply. Water only. Question 5. Is calcium hydroxide, that's CaOH2, an Arrhenius base? Pause. Yes, look at the formula. Calcium hydroxide, it's got OH in there. Actually, it has 2 OH minus ions. That makes it an Arrhenius base. If you got all of the 5 questions correct, you are solid on the basics. If you missed any, review the definition and diagrams. Don't move forward until this makes sense. Now let's level up. These are application questions. You are going to write equations and do calculations. This is where we actually use what we learned. Write the dissociation equation for sodium hydroxide in water. What is the equation? Let me see if you can do this correctly. So NaOH breaks down into Na plus and OH minus. Everything is aqueous. Make sure you use a single arrow, not double arrow. Strong bases like sodium hydroxide completely dissociate, so we use a single arrow going one direction. And when you put aqueous, this shows everything is dissolved inside water. Let's see the next question. Let's delete this first. Question number 7. Write the dissociation equation for KOH inside water. Is this easy? Yes, the same thing. The KOH, the aqueous one, goes to K plus and OH minus. Same pattern. KOH is potassium hydroxide. Aqueous splits into potassium aqueous and hydroxide aqueous. 1-to-1 ratio. This gets a positive, this gets the negative. Very good. Let's move to the next one. How many OH minus does calcium hydroxide produce per molecule? The answer is what? Let's do equation. So calcium hydroxide breaks down into Ca2 plus and OH minus. But look at the balance. That subscript outside the parentheses means what? Means there are 2 OH groups. So one molecule of calcium hydroxide dissolves, or 1 formula unit, it produces 2 OH minus. Let me write this in red so it will be clear. The 2 here must produce 2 here. That's important. Some bases produce more than 1 OH minus per molecule. Now question number 9. Complete this equation. Let me just delete this first and then ask the question. Lithium hydroxide produces what? Again, the same. The lithium hydroxide is gonna divide into 2. Is it 2? No, it's not 2. It's LiOH only. Why did I write 2? It's 1. So this is aqueous. It breaks down into Li plus, that's aqueous, and OH minus, which is also aqueous. The last question here is number 10. It's gonna ask me, does Arrhenius Bases increase or decrease pH? Think about what pH means. If you are revising the unit, then this is good for you. If you are starting, and this is the second video only, you have not taken this one before, so you need to revise this first and understand it. So don't do this question. But if you are revising unit 8, you know that when OH minus increases, the pH of the solution is gonna increase. Again, if you are new, don't do this question. Only if you are revising the whole unit and you have already taken everything, you can do it. Now, the final stretch. These are challenge questions. They require you to think deeper and explain why things work the way they do. Take your time with this, pause after each one and really think it through. Explain why HNO3 is not an Arrhenius base. Don't just say because it's not. Explain why. HNO3 plus releases what? HNO3 plus reduces H plus ions and NO3 minus. So it produces H plus, not OH minus, making it an acid, not a base. Which produces more OH per molecule, NaOH or calcium hydroxide? The NaOH produces only 1. It gives you 1 Na plus and 1 OH minus according to the balance, while calcium hydroxide produces 2. Calcium 2 plus and 2 H minus. This is very important for the calculations. You must master this. If you have any issues with this one, you must go to the videos of the stoichiometry, but simply the ratio is 1 to 2. Substance increases OH when dissolved in methanol. Is it an Arrhenius base? No, it requires water, not methanol. What is the conjugate acid of OH minus? Again, this is for you if you are revising the unit. If not, then don't do it now. OH minus is a base. When it gains a proton, it changes into H2O. Why does higher OH minus means higher pH? Because when OH minus increases, this means the H plus less, and this causes the pH to increase for sure. And that's it. You just completed skill 2, Arrhenius Bases. Give yourself some credit. You just worked through 15 practice questions. Let's recap really quickly. Arrhenius base produces OH minus in water. That's the definition. Common example is sodium hydroxide, potassium hydroxide, calcium hydroxide. Anything with OH in the formula. They increase pH because more OH minus means less H plus, and they only work in water. That's an important limitation. Now, here is what I want you to do. Download the free worksheet for this skill. The link is in the description below. Print it out. Do all the 15 questions again without looking at the answer, and make sure you can get the 15 out of 15 on your own. That's how you build the real mastery. Repetition. Practice doing it yourself. Next up is skill 3, Bronsted-Lowry acids. That's where we expand beyond Arrhenius and look at a broader definition of acid. It's going to build on everything you learned here. If you found this helpful, hit that like button, subscribe to the channel, and drop a comment below telling me how you are preparing for the AP exam. And remember, you have got more skills to go, but you are building momentum. You are going from I don't get it to I ace it, one skill at a time. See you in the next video, and keep practicing and do your best.